wait for it. There! Did you see that? That sudden flash of light? Pretty fast, right? That's exactly what radio bursts are like. Bright, powerful blasts of radio waves that vanish in an instant. Just recently, scientists spotted the brightest one ever recorded. But there's something scary about it. Although we know exactly where it came from, we're not so sure what produced it. Meet our powerful cosmic firework, RB float. Picture it like a lighthouse beam, but instead of shining visible light, it's shooting out radio waves. These flares are insanely quick, taking just a few milliseconds, but that's enough time to outshine the entire cosmos around them. To put it in perspective, one of these bursts pumps out more energy in a blink than the sun produces in an entire year. And they're so ridiculously bright, we can spot them from halfway across the universe, several billions of light years away. Flares like this happen from time to time, true, and most of them slip by unnoticed. That's true too. But RB float is different. It's being considered the brightest of them all. It was so bright, in fact, that at first it was flagged as radio frequency interference, like weird signals they'd expect coming from airplanes or cell phones that are much closer to us. And that's not so strange when you consider what happened back in 2024. Astronomers thought they were seeing a fast radio burst from far beyond the Milky Way. In the end, it was just a signal from an old NASA satellite called Relay 2. Okay, so let's get back to our recent discovery. It actually took a moment before astronomers realized, wait, this isn't interference from a plane. This is a real cosmic signal. This eureka moment happened on March 2025. The flare was picked up by a telescope called the Canadian Hydrogen Intensity Mapping Experiment, or simply, CHIME. This is a massive array of half-pipe-shaped antennas out in British Columbia, Canada. After the discovery, the team quickly teamed up with a bunch of other organizations to tackle the big mystery. Where did this flare actually come from? Now, trying to find the source of something like this is kind of like looking for a needle in a haystack. Actually, it's much worse than that. Because in this case, the haystack is the unimaginable vastness of the universe, and the needle, well, it disappeared. You see, this powerful fast radio burst wasn't pulsing over several months like they usually do. Instead, it dumped all its energy in a single burst, and then it was gone. Even after hundreds of hours of follow-up, astronomers never caught it repeating. Eventually, they just gave up, waiting for another flare to collect more data. And this means they only had one shot at pinpointing its location, which made the mission even tougher. To get a sense of just how quick these bursts are, picture you standing in New York and a firefly in Florida flashes for just 1,000th of a second. Now, trying to pinpoint where that signal came from is like figuring out not only which tree the firefly was on, but even which branch it was sitting on. Sounds like an almost impossible task, right? But it's really important to figure out the exact location of these bursts, because if scientists can pinpoint where they come from, who knows? Maybe that's one step closer to uncovering the real cause. And maybe, just maybe, this could finally shed some light on the true nature of these mysterious fleeting signals. The thing is, scientists have known about fast radio bursts since 2007. But ever since then, there's still been a lot of debate about how they're actually produced. Some theories point to rapidly spinning neutron stars, basically the leftover cores of bigger stars that rotate insanely fast. Others suggest black holes. And yes, there are even those who've wondered if it could be some kind of extraterrestrial intelligence, like a high-tech cosmic spotlight. But recently, researchers found a new method to track down at least one of these bursts. Back in 2022, they spotted a radio burst that flickered, kind of like how stars seem to twinkle in the night sky. They decided to follow that clue, and it worked. They traced the signal back to a spot incredibly close to a neutron star. The gap between it and the radio burst was actually smaller than the distance from New York to Singapore. And in space terms, that's practically nothing. Because it was so close, scientists believe that flash came from right around the neutron star itself, in a super magnetic region. This was the very first time they proved that fast radio bursts can come from the magnetosphere. And by that, I mean the magnetic bubble surrounding a tiny, ultra-dense star. Great. So, did the same thing happen with RB float? To find out, scientists first needed to track down its exact location. As I mentioned earlier, it was first spotted by CHIME. This telescope began operating in 2018. Since then, it has picked up around 4,000 fast radio bursts from all different parts of the universe. But there was a problem. CHIME couldn't actually pinpoint the exact spot in space where each burst was coming from. Or if it did, the process took forever. That is, until now. Thanks to a big boost in precision, this telescope can finally locate these bursts with extreme accuracy. It's finally catching these fleeting cosmic signals in the act, narrowing down their locations not just to individual galaxies, but even to specific stellar environments. The tech can also localize single non-repeating bursts. That's a real turning point. It opens the door to figuring out whether they're triggered by fading stars, bizarre magnetic space objects, or maybe even something we haven't imagined yet. And that's how they figured out where RB float came from. Turns out it's one of the closest fast radio bursts ever detected. It happened about 130 million light-years away in the constellation Ursa Major. Cosmically speaking, that's practically in our neighborhood. And that means it's a fantastic opportunity to study this phenomenon in incredible detail. For example, astronomers were even able to estimate how deeply the burst is embedded in the surrounding gas. And it turns out it's relatively shallow. But here's the really exciting part. They discovered that the explosion came from one of the spiral arms of a galaxy. And spiral arms are usually packed with massive stars and newborn stars. In other words, it's a place where new stars are born after giant stars reach the end of their life. So it makes sense that in the middle of that process, quick and powerful bursts could erupt. And that could explain RB float. Now, the mystery comes in. Remember how I said CHIME is now super calibrated and can pinpoint locations with amazing precision? Well, this radio burst turned out to be near one of those star-forming regions, but not inside it. And that's really strange, because scientists expected it to be right in the middle of the action, within the clump of newborn stars. But it wasn't. That means that even though we can now pinpoint the location of these bursts with amazing precision, we still don't really know what they are, or exactly where they came from. At least that's still the case in many instances. Even so, this new discovery is really important, as it brings us a step closer to unlocking their secrets. One of the biggest mysteries we still need to solve has to do with their pattern. I mean, do they send out repeating signals, like a cosmic heartbeat? Or are they more of a one-off, releasing a single powerful signal before going silent? Well, we don't have the exact answer yet, but the future of this field looks really promising. With hundreds of precisely localized events expected in the next few years, experts will finally be able to study the full range of environments these mysterious signals come from. And they're convinced the RB float discovery is only the beginning.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.